Good morning, folks. How's it going? Gonna get a good stream in, probably 7-8 hours. Not my usual 10 plus for Saturday, but it is Valentine's Day. Oops, let's do. There we are. Hey, Pepe. Stream work on Saturday? Saturday is usually my longest day, Alex. Though I think today is just going to be a 7 or 8 hour stream. And I'm here late as well. All right. Let's see where we want to start today. First of all, let's just check if I have anybody messaging me. Do we have anything from Peru or Jonah? No. Okay. So neither of those two contributors. Hey, Jan, welcome. I believe Peru is still doing some profiling stuff on environments. And we also have Jonah doing some kernel stuff. So I think there are a few goals I have today. I really want to get this into a spot where we can make, generally make broader use of this. I guess let's just take a few minutes to go through the remaining complexity. Because we did this. This is still to do. Remaining complexity. So we have a whole ton of init, teardown, CUDA graphing, and PufferLib.cpp. I don't know how to fix this while leaving torch in. We also have +1 layer indirection because of kernel versus native torch path. Is it 1 layer or 2 layers? It's 2 layers, isn't it? Because it would just be launch. So we can consider making this 1 layer. Has it gotten busier and are we getting less streams? So I would say temporarily, because I am personally working on 3 client contracts, and Puffer's got 4 of them active. 4 or 5. 4 main ones active. And one of them we just signed is a much bigger one. So I have a fair bit of client stuff to take care of, and it was supposed to be spaced out. But over the holidays, a couple clients didn't get me stuff when they said they would. So everything is stacked up at the same time. So at least a few days a week now, I need to be doing some of that. That said, I'm also in Florida. Florida's a little bit less productive than Maryland for me because there's like travel time to and from gym and stuff. And, I got stuck in traffic like an hour yesterday. There's all sorts of things that get in the way. That said, there will still be streams. I'm still aiming to get like a minimum of 3 solid stream days in a week. And I'd like to be doing more than that as well. But that's what I've got bandwidth for at the time being. I'm here like 7, 8 hours today. What kind of contract work are we doing? So, what the heck happened to my camera? All right. So professionally, Puffer builds high-performance RL sims, and we solve RL problems for people. Like that is the business. So all of Puffer is open source, but Puffer is a company. It's a couple companies actually, and we do offer professional stuff. Right, we were assessing all the remaining complexity in here. Modules H, advantage. Muon is very minor. Muon. Modules. It's nothing. It's like 750 lines of code that doesn't do anything, right? Like if you think about it, the torch modules really doesn't do anything at all. I think that is most of the remaining complexity though. On this Python side, it's mostly sweeps. Okay, so I think then the one thing let's at least figure this problem out real quick first, this indirection thing. So the way I have it, I have this like if kernels. Oops. Right, so I have all of these functions down here that have this if kernels path. Right, if kernels do this, otherwise do this. Wait, why do I have it this way? I think I just did it this way because I have, like, the custom nets have to do it this way, right? Oh, I mean, there's also, like, it's because they're like these chunks of shared logic that are kind of annoying, right? I think this is kind of okay then. At least this is not clearly bad to me. Like, I see where this complexity is coming from. I understand why we have it, and I see how we're going to get rid of it in the future, but I don't see if there's a clean way to get rid of it now. So in that case, we have a couple things we can do. There are a few minor things where I know I'm going to find some areas for cleanup. There's like the general just culling through the code, trying to fix things. See, at the same time, we really want to be able to start running experiments. I'm trying to think, like, what would be the thing that is going to help us the most for 4.0? And I think it is really to just start getting some of the experiments going and stable. Like, there's going to be some cleanup I have to do for the Python side. That's annoying, but not particularly hard. I have a bunch of writing to do. I have a bunch of, like, minor refactoring to do. But I think for feature complete, like, basically stable and ready, we mainly just need to have the experiment results and such in Constellation. Let me go take a quick look at those results then. I'm trying to figure out what we do about that though, other than like, what do we do about this other than just running the experiments? Yeah, see, we're at min clip coef. I really don't like this. Because look at this, right? This is really, really bad in my mind. Like, okay, maybe I should explain because this is probably not obvious to people. So, Puffer is working perfectly. The sweeps is working perfectly. What this is saying is that the best hypers it found for 2048 have a clip coefficient of 0.01, which is the minimum possible. And like, look at all these experiments that are pretty well performing. And then this is another set of sweeps I did where I capped it to be no less than 0.1. It's way worse. I suppose this could be a bug with how we have Puffer implemented. I'm going to try two different things. Let me sanity check, because I think this is equal to sign descent. I think it ends up being sign descent. Yeah, see, this is where the LLMs completely fall apart, because it's going to say, that can't possibly be, yada, yada, yada. Well, I have the result right here. Okay. Second possibility. Would be this. We're updating the ratio. Are we supposed to update values is the question. I think it might be because we're updating values here. So I'm trying to figure out why it's doing this ridiculous clipping. We do have a couple things weird. Let me try something real quick. I don't want to bias it. Unfortunately, it probably has some PufferLib like code in the training data for Claude at this point. I just want to bounce some stuff because I'm basically here. I'm pretty sure that the ratio update is correct. It's possible the value update isn't. because there are kind of two possibilities here, right? One is that we're just doing a really wide hyperparam sweep and we're discovering weird trends that people don't notice before. And the other is that some of the stuff we've done in Puffer 3 is kind of jank and produces these weird trends. And like, we're basically just making stuff stable in spite of it by clipping hyperparam sweep ranges. Let me go look at new value. So advantage gets computed via values, rewards. I mean, the thing is, this does give you the advantage estimate. I think possibly it's the importance sampling is wrong. What do you think about prime intellect? They're funny. They do LLM RL though, like it's pretty different stuff. And I don't really follow a ton of LLM RL. I have one of the group chats I'm in on X is like the prime people. Placement, okay. Are we getting the importance values correct? I'm a little confused. Rollout.ratio. Where am I computing ratio? MB ratio is in compute train loss. Launch videos are gorgeous. I haven't seen any of them. I do actually need to get I need to figure out what I'm gonna do for Puffer 4. I'm probably gonna have a nice launch video. Hey user. Aesthetics of launch video. I mean, honestly, at the end of the day, it's the cold hard thing that you've built matters the most. And like, yeah, you can lose on the other stuff, but hey, you're not gonna win on it. Though I guess lose and win versus what, right? It's kind of impossible to lose if you're not on a tight like funding burn rate rope. I don't know, more and more lately I've found clarity in just ignoring what all the other startups and all the other labs and stuff are doing, and just solving the problem. I will do a few things for the Puffer 4 release though, just so that people see it. But until then, I think we just make sure that we actually make it good. I think what this would be. Train loss. Ratio out. This old log probs. Wait, logit's values. Logit new value. How does this make sense? Dario interview? Hell no. Absolutely not. The main questions I have in my mind at the moment are like, can I make this thing good enough to ship with Torch in it like this? You know, at what point is it going to make sense to rip out Torch completely? To what extent can I like provide chunks of my stuff to bindings to the Python version to give at least the Python users some level of performance? Like, these are the questions I have in my mind. Yes, okay, so I think I do actually have a problem on value function change here. Ilya that brilliant compared to his peers? What peers? There are a few brilliant people in AI. But for the most part, it's just a lot of the people that you look up to are actually complete morons, is more the way that it goes. I think that's true in a lot of places. There are very, very few actual geniuses, but there are a very large number of morons pretending to be useful. Um, and Ilya was always quite sharp, quite prescient, very, very well spoken, and not in a bullshitty way either. He always had a lot of respect for him. Dario, Sam. Okay, Sam should not be on that list at all. Sam is a fucking conman. Radford's awesome. Dario is at least technically capable and very smart, but completely delusional. So that's like the most mismatched list ever right there. Nice cup, thank you. I'm thinking I should get a bigger one. This one's too small. Well, I see why the VF clip coef would be pushed really down. How are we doing our clip? Max norm. Okay, so you're clipping grad to a max norm, right? That ends up just being a downscale. I'm trying to think what else would cause this issue. So I definitely see a spot where we could be screwing up our VF clipping, and that's a very long-standing thing with Puffer. Is VF clip coef being pushed down? So I could see this being a very useful enhancement. Or correction, rather. I don't see anything that would push the clip coef down. Guess maybe the fact that it cranks up the replay ratio. Why the heck would it crank up the replay ratio? That also seems weird to me. Yeah, look. Why we have noticeably better results with a higher replay. That's super sketchy. Wait, what's this? Ooh. Hang on. I think this is a bug then. Oh, this is evil. Yeah, this is evil. Okay. Let me see if this is actually correct. Dot contiguous allocates a new tensor. It is a copy, not a view. I think that this is correct. Writes to original. Wait. Hang on. Rollouts buffer. Okay. Oh, that's super evil. The write backs go to PufferL.rollouts. The reads come from rollout star. Do they? This is such a big bug if we find this. It would explain a lot. So then this is basically just never updating this code, huh? Must have same shapes. Actually, let's do one thing first. Let me actually understand what this would cause first. This is very, very important we get this right. This could fix the remaining problems with Puffer. And then this could literally be we fix this in our next sweep's work. And then basically it's just pure cleanup to 4.0. This is how substantial this would be if this is actually what's happening here. And this would also, the other thing that we just found would also resolve a long-standing hyperparam issue we've had with Puffer. You don't ever update ratio. You don't ever update value. And what happens? Hey, Red Swag. This means ratio is always 1. You just don't have important sampling on this. I think you still have important sampling on the segment level. But this basically nulls puff advantage. That would make sense why the values for that are all over the place. Does that explain why it would have a super low clip coef though? I don't think it does. Open loop priority sampling. Oh, it's because we're sampling the same thing over and over, right? I think it does explain it. So the aggressive clips would be because we're sampling the same thing over and over. Repeatedly sampled, yeah. Okay. We don't need this one. Wrong window. If this does not immediately solve breakout, we're not going to be sad because we absolutely will have to resweep after this. Okay, so wait, rollouts, values, index copy. Eh? Index. I did drop the transpose. Is wrong. Index select segments. Right. Yes, that's fine. Okay, so if this does not solve breakout, we're fine, as long as it learns something. If this learns nothing, we're a little bit suspicious. We still have to solve the value bug, though. Okay, you know, it still does reasonably well. Completely off hypers. We're still at, well, that was weird. It got 600 and something one run, and then you saw it got nothing the next run. Super unstable is fine, though. Super unstable is fine. I think we just need to add old values to rollout buff. I'm just having this essentially do extra checks. You know, unfortunately, I am sort of acknowledging that this the way I have Puffer now, it's not really great for being able to make quick little edits to things and have all of the code context in your head. It's good for research in the sense that it lets you just run a shit ton of experiments. I mean, it's also way simpler and faster than the other high perf code bases, but we do trade a little bit of simplicity off. MB returns is now advantages plus old values. Okay, so it's unstable, but it does train. Let's just see if it finds jank. So we've completely broken breakout training. What on earth are we taking all this time doing? Batch is 2730. How the heck do we get batch 2730? Oh, 3 buffers? That doesn't divide, does it? Huh? Okay, we're gonna kill this. We're just gonna assume that something is wrong here. We'll do like this. So what is wrong with this? Why is this taking so long to make a new run? Oh, it's probably Wanvia knitting, right? No. Huh? Forward. The heck is going on here? Could it be setting? Mini batch size, it could be setting weird, I guess. We'll just do 4096. Probably sampling something stupid. There we go. See if within a few runs it finds something non-trivial. VF losses are insane. Wait, are they always insane? Looks like it. Did not seem particularly good. Let's try. Zero, 1, or 1, 0. Alpha 0, beta. Okay, let's try this. One. Yeah, there's no way that lambda should be 0.6. We should have seen that immediately. Yeah. There we go, right? Immediately something reasonable at least. That ought to seed it with something. Math domain error. Lovely. One minus. I see. What? Okay. I think we got stable sweep. I'm gonna let this run. I will be back in a few, and I'm gonna do a couple things, get myself a cup of tea, and then we will see if we have fixed PufferLib. I'll be back. Oh, well, that looks good. At least we are, yeah, those are real runs. Cool. You did ban this bot. I'm gonna get my my tea, and then we shall see. I think I might have just fixed a super long-standing puffer bug though, and a really bad puffer 4 bug. I think we just did both at once. That would be exciting if so. I am here. I have an excuse. When asked to make breakfast on Valentine's Day, you make breakfast on Valentine's Day. Let's see what we have out of 140 experiments already. Lovely. Oh, beautiful. Look at this clip co-op. Very, very reasonable clip co-op so far. Very reasonable VF clip co-ops. I think these are slow though, right? Oh, not even that slow. Let's see. This is 6 seconds. 41. 4 seconds. Yeah, this will be good, guys. Holy. I think we just found. I mean, if this is the case, then this is the biggest like bug fix to Puffer in a year. Well, I mean, it's like a moderate bug fix, I think, to Puffer 3, and a very, very huge one for 4. But this should push us under 3 seconds. Hey, Liberty. I think we just found a massive bug in Puffer 4. And it's the good type of bug. It's the type of bug where your results are still valid, and your results should be much better after you fix it. So, the bug was essentially it's using the wrong, using a new value function for the target in VF clip will mess up your clipping. And then specific in Puffer 4, we were not copying data correctly to update the new value and new ratios for advantage. So we were using stale advantage function. So yeah, that's a very major bug. Even if this doesn't get us faster solves, if this gets us the same solve speed as before and stops us getting super jank hyperparams out of our sweeps, I will be very happy. Because honestly, like, the jank hypers thing is the one thing that still just has me annoyed, where it's like, you know, maybe RL is still a mess. Yeah, that's really good. $149 experiments as well, since I just went down to make breakfast. Super fast. It's a gigabug fix. Now we do need to let this run more. Well, here's what I'm gonna do. I went and I made breakfast. I'm gonna go grab my plate, and I'll sit here. We'll let this run for a bit. I'll have some breakfast. Oh, perfect. One moment. Okay, well, let me just watch this for a little bit while I have some breakfast here. And then I guess I want to let this run a bunch, so while we're getting full data, I'll commit this. I'll move dev to my local, and we'll do some of the cleanup that we were gonna do. We'll do stuff where we're very unlikely to break anything. And then once this has gotten a full sweep by later in the day, if the results are good, then we'll queue up 2048. And then hopefully we get a 2048 sweep with less jank hypers. And if we get that, then it's GG, we win. And then it's like, yeah, Puffer 4 stable. This fix purely just came from like thinking about the experiment data a bunch over the last couple days for reference. I don't know why the hell there's an experiment out there at like 70 plus uptime. That's weird, but no, whatever. Oh, I just noticed. Look at the look at all the names. They're all Valentine's Day themed. See, this is how you know that Weights and Biases is a professional company, because if I were going to make custom named experiments for Valentine's Day, they would all be like log off, touch grass. Am I just stupid? Theming. Does this stupid dictionary do this? Gaslighting Linux dict. No, let me enter this 1 second. I mean, Ange, most of the hype is bullshit. AI research is not at all automated. That's why they're still hiring tons of people and pouring billions and billions of dollars into R&D. Um, they have more researchers now than they ever have before. So most of that stuff is just hype and bullshit, and you kind of just need to know what you're doing. So don't spend a ton of time like trying to learn to use AI tools to help you or whatever because they're dumb. Um, they have no learning curve if you do want to use them. The thing that still has a learning curve is like low level dev, architectures, algorithms, all the tensor shenanigans that go on. Like all the normal stuff is still the normal stuff. So I guess don't over index on AI for AI. Layers. We getting some more reasonable values. Oh yeah, these are reasonable values. Matched learning rate. Mm. Yeah, I'm gonna finish my toast. We're gonna sync this up, and then we'll start cleaning some things up. Okay. We let this do its thing here for a bit. Now I'm on my local machine. That's a crazy, crazy bug to have found. I mean, now I'm going to just be wanting to look at this all day. But the best thing is to let this run and like focus on other stuff. Okay, so if this is the case, then stuff to clean up. A few things. I don't want to mess with the sweeps code because of that, though. Let's go check our rollout buffers. I want to see how we're using these. I mean, these signatures suck, right? You're passing graph.everything. Yeah, I really do not like this. Okay, I think there will have to be a little bit of plotting today, but like not for... I think it's going to be mostly a couple basic cleanup things that I've missed. So like very well-defined stuff. I still hate that I'm doing it this way though. What's the alternative though? I guess inlining it here. We could totally just inline it, can't we? Well, wait, no, the problem is that we want to have it profiled, right? Yeah, we can't inline it because we want to have it profiled, right? That was the problem. I see, I remember. This type of work ends up being a little bit slow because it ends up mostly being me just like thinking about how do I make this code not suck. I mean, it's one of these things where like I know exactly how users are gonna feel looking at this. I'm like, well, how do I do this in a way that they don't hate this? While also letting me still be able to profile it correctly and all that. Because right now it's function here, because it's defined in models, and then it's defined in modules. I think it's one redundant layer of abstraction, right? This one's easy. We just do this. Boom. We take the sig. Boom. Right? And then we unindent this entire thing by 1. Okay, so we can start with that. So where's train selecting copy? If papers.kernels. Whoop. Same call sig. Okay, right? Else. Same thing. So ignore the fact that these sigs are massive for now, right? That's minus one layer of abstraction. I like that. Can do the exact same thing here. Just copy this. Yes, that's the exact same thing. Cool, so we take this. And then compute file. We just do if kernels. Can we do that? We totally can, can't we? What do we think about this? Yeah? Same length, minus one layer of abstraction. Or rather, one layer of indirection, I should say. Kind of same thing. Is there any, there shouldn't be any overhead calling it this way, right? I don't think there should be. Alright, what about this one, like compute train loss? How about this? I mean, I don't see any reason to have this be separate, do you? Effort lets you control. Do this. It's a really simple. You shouldn't be using it for very heavy stuff anyways. But why am I reaching for this? I shouldn't be reaching for stupid Claude. There's something about the code that's wrong if I am. I mean, it's literally just a shitty torch and I don't like touching it, right? I don't do this when I'm writing C. Sometimes I ask it about math and stuff, but I end up writing the code. Now I'm curious. What happens if I just try to edit this manually? What happens? You get PPO loss, optimize function. Ah, okay. So this is why I'm reaching for Claude, right? Because watch what I have to do for this bullshit. I end up having to like this gets a dot apply. Yeah. Now I know why I'm reaching for it. Okay. This is actually not a bad thing then. This is not me being lazy. Is it okay if I use pathfinding in an environment? I don't know if this is considered cheating. Well, for what? Like, we have a couple environments, I think, that use pathfinding. The enemy AI uses pathfinding in MOBA. That's a very common one. There are definitely cases where, like, if like pathfinding is appropriate. Now, the thing you got to be careful is pathfinding can be very slow. So if you can cache it, if it's a very small map, it's often possible to cache all possible pathfinding ops. That tends to be useful. In fact, the RuneScape environment that I have, like the RuneScape thing that I have, is going to require a very efficient A-star implementation. Funny enough, so like there is absolutely case for pathfinding. I think usually you use it for the enemy AI, and then for human control, you can use it for the agent, but I don't know if it makes the problem easier a lot of the time. Like, what do you want to do with it? I suppose is the question. So the reason that I find myself using Claude here is because Torch is shitty and all the code is super redundant. Lo and behold, um, we just try to make the code a little less redundant today. It's all. There's going to be a limit on how well we can do it, but we can start. Quick experiment update. Not bad. 2.9 seconds for 744. Old Bomberman mechanic, we have randomly roaming enemies to run to the target. Oh, dude, like that. Yeah, Puffer will just insta-solve that. Like, the Puffer doesn't need pathfinding. If you want the enemies to have pathfinding, sure. Like, Puffer is really, really good. Any of these sort of relatively simple arcadey tasks, it'll just insta-solve as soon as you have the end correct. Sometimes I have reward stalling. Have you looked at what the model is doing? Have you tried to play the game yourself? Have you looked at the obs? Have you looked at the reward? Like, if it's the game that I'm thinking it is, Puffer will insta solve. So most of the time, I see a lot of the newer contributors around here. They try to get too fancy on their env to make it easier for the RL. But you gotta understand, the RL's really, really freaking good, and most of the time it's you've done something silly with this env. Or you have silly hyperparams, or silly reward or something like that. Okay, cool. What is reward stalling? Like the agent gains reward, just like the thing stops learning, right? Like reward plateaus. Okay, so cool. What the fuck? Standard deviation value. Mock props. Exercises, losses. Where does it get is continuous? Hey Lalo. Hey Ashwin. What are you working on? Looks interesting. I believe you're new here. So this is development on PufferLib. PufferLib is the highest performance reinforcement learning library. We have a bunch of demos here on puffer.ai. We currently have training in dev over 15 million steps per second on a single GPU, which means you can do RL on simple to medium complexity tasks in seconds, and quite hard ones in minutes, oftentimes. I stream all the development on it. At the moment, this is a mix of refactoring stuff up for the next release, fixing some major algorithmic bugs, running tons of experiments, going back and forth and checking those. Lots and lots and lots of dev work on the project overall. It's all open source, and sometimes you'll also see me working with contributors on stream as well. That's the idea around here. Let's try this. And then this should just be one path. One shot League of Legends with Grok. Not happening. If they're not training specifically on League, it will be a complete failure. I don't know what his deal is with AI lately, because I mean he's kicking ass with SpaceX and Tesla and a lot of his other stuff, but some of the AI comments are just completely fucking dumb. And I don't think Grok is anywhere near as bad as like a lot of the other people are saying. Like the lab overall, it's doing decently well, especially for how small it is and how recent it is. But some of the stuff like just doesn't make any goddamn sense. Like literally, how does that even make sense? Like, oh, okay, you're gonna make really, really good AI trained on a bunch of stuff, but not specifically League of Legends. Cool. So there's not a single person in the world that can one-shot League of Legends without having played the game quite a bit. I don't even think that there's a single person that can like who's never played League or at least like a very adjacent game can get to top of ELO bracket within even a couple of months. Like it takes a shit ton of practice and domain specific experience, not in the training data. Now look, if they're gonna fine tune on the data and they're gonna do like, gameplay like pixels on that, they're gonna train on pixels and like sure they can get an inefficient thing that works. But I think that the best possible case for them is that they get a less impressive result, a less impressive version of OpenAI 5. Because OpenAI 5 like was already done and it's the best result in RL. Dare say otherwise. I mean, I would doubt that. I mean, if so, that's their problem. Wait, what? I already did this. Wait, what? Okay, I think you can do this. I think you're allowed to do this. Turn. Okay, this is gonna be some weird torch thing. One path. Cleaner. Right? What in the hell? Yeah, this is some C++ jank. This is some C++ jank. Terrible language, really. Probably it's the SIGs are different. They should be the same. Oh, there you go. Hello, Chief Puffing Officer, long time. How's it going? We are doing some simple refactoring of stuff to make the code less awful, and we are waiting on a bunch of experiments to run. This is not bad. We've got, it does seem we're getting this elbow, though, around 5 seconds now, which is concerning. It should not be slower after the update. It should be substantially better, if anything. It's only had 300 experiments, though. How many hours do you work in a week? It depends. I mean, I mostly work when I feel like working. Maybe a little bit more than that, but... I mean, I started a little bit late today, and I'm ending a little bit early since it's Valentine's Day. Okay. We're not expecting this to solve for reference. These are untuned params. Yeah, crit. Got plans later, but working right now. Okay. Well, this is much better, at least. See if we can understand why it's like this. Apply. I don't think we need this at all, right? Autograd wrapper. So you see this gross thing? Like, look, these functions already have big signatures, and then you end up having all these, like, these dumb wrappers around this. It's required by the PyTorch C++ API. You have to register a Torch autograd function subclass. Apply is just the entry point. Let's see, what do we call this? What's this AI you're using? Which AI? If you mean this is just Claude, which is totally stupid, but it's fine. Like, I'm not using it to do AI. I'm using it to apply very well-defined refactor operations to very stupid code. These AIs are things that I've trained. Some of these are my environments. Most of them are contributed environments that are now part of PufferLib. And these ones train super fast. These are tiny little models. Some renames. Yeah, that's a nice refactor up. Internet and typing speed. Well, the internet better be fast, because this machine I'm on. First of all, this is just an SSH instance. I could easily have this moshed, and then latency would not be a factor. But yeah, this is part of the Puffer cluster. I think we still have pictures on the website. Oh, this was the old one. Where's the new Puffer cluster? Oops. Stupid thing. Here, I'll show you the new Puffer cluster. I'm usually streaming from there most of the year, but summer and winter I'm elsewhere. Of the oh yeah, there it is. We got all the machines in the background. We got the gym and compute cluster combo. It'll be fun. I'll be back there when I want there too. Do you work off live stream? Yeah, but I mostly just do client work off stream. So most of the open source stuff is streamed. And sometimes I stream a little bit of client work if it happens to be open source. But most of our client work is like closed source custom sims. That's sick. Yeah, it's a fun setup. I mean, I'm kind of in the middle of nowhere there, so I sort of have to have all my own stuff. And there's lots of space, so why not? You'd be shocked how cheap some of the gym equipment is. Like that whole dual tower stack, I think was maybe 2 grand. I get good use out of it. Mm. Tony Stark house. Iron Man 3. Why 3? The original was perfectly good, no? I think that's like the only, not even really superhero, but adjacent movie I've ever seen was the original Iron Man. That one's pretty cool, because that's like actually kind of what nerds want to do, is just have their own lab and build cool shit in peace. Out of nowhere, yeah. What the fuck is this shit, man? I need to add the wrappers back. Hello? Part of the point of this was to delete the wrappers. Just call apply directly. Moron. Sees modules.h. So we can't call unless the class is visible. Class definitions. Okay. Minimal class X in modules.h. Stupid. See you around, man. Everything in AI is just named the opposite of what it is, I swear. Reasoning models can't reason. OpenAI, closed. Anthropic is misanthropic. Every bloody time. Okay, this is totally fine. This is just minimal dex. Full class definitions. Stupid C++, I swear. I can't wait until the day that we just delete Torch entirely and we just do raw CUDA. That'll be so much better. I don't know what dystopian hell we've ended up in where, like, people have just stopped giving a shit and are just submitting AI slop code, and uh, even though they're not bothering to read their stuff anyways, they're still doing it in like Python and TypeScript and crap. Like, at the very least, if you're gonna automate yourself out of the loop, can you submit like some nice C code or something? Like, those languages were created so your dumbass could understand in the first place. So if you're not gonna even bother, we may as well just have C. What the hell is this crap? Public. Wait, torch? Ah, okay. I didn't know you could do this. But then again, I don't really write C++. So I actually like this more. I actually like this a lot more. This is going to be way nicer, right? Because look. Yeah, now these look like functions. These are now just functions tied to structs. So I always hate the extra indent level from classes. This is actually way, if we have to do this, this is probably the way to do it. That's way better. And I highly doubt this breaks it with this simple refactor. Yeah, it's literally just moving like class definition under two. See, I legitimately didn't know that you could do this in C++. That actually makes me like the C++ classes way more. Nowhere near enough to use them by choice, but way better. It's gonna make it a lot easier to port to C, because you basically just delete those defs and you're good. I'm excited to see how much code we've deleted by doing this. Can't take its address in the same way. Really? Static member function template can't take its address in the same way. That's giga bullshit, though. Oh, that's disaster. That is mess. Point. Let's keep. I can't make it. Sig. Fucking C++, I swear. You could do this in C. Ah. Non-template function. Where's the templating anyways? I don't see templating. Variadic. take a variable number of arguments. Huh? Is it the backwards? Great. Fucking stupid. Autograd function class. I hate that. I hate that so much. Every single time I come up with something like reasonably clean, I end up butting heads with the torch code just being absolute unadulterated garbage. Like, what the fuck is this? Variadic template. Why does this exist? Who came up with this and thought, yeah, let's do this? So now, even though I have a function that takes the exact same argument list, I can't just decide, let me use the function pointer like this. Instead, let's rewrite the entire function out like this. Or wrap the function in yet another layer of indirection for absolutely no reason. This is why we don't have nice things. Programmers are idiots. I'm trying to think how I want to handle this. Don't want a fucking wrapper. Okay, I think I know what I'm going to do. 1 second. had to go answer some questions. Hello, Jess. What are we up to today? We fixed a major bug, and there's no timeline, but we're still working on it. I think that will work. Where did our experiment go? 4.4, 5.29. The fuck is this? Absolute imbecile. Apply because AutoGrad needs to track individual tensors. Annoying. Annoying, annoying, annoying. So we can't even do that. There can just be no nice things. Thanks, Torch. Well, we're sure as shit not doing this. Idiot language model. Ah. Torch, why is it like this? I'm trying to think what we can do. I mean, on one hand, I don't want to spend all of my time today fighting Torch's just stupid code. Like, there are a million ways that I could do this, and Torch is just blocking all of them. Cleanest is just an if statement. Lovely, shitty anonymous function bindings, my favorite. It's just truly unbelievable. I swear, programmers are some of the smartest and some of the dumbest people you will ever meet. I mean, it's like when you see stuff that's just so simple and clean and takes a hard problem and just like cleanly splits it up into like this and this and this. It's like, it's just very, very clear logic. Honestly, some of the closest, it's like the closest thing out there to just clear, pure thought in my mind. But then you see like people that they go like, oh, we need to solve A to B to C. Let's do to A to D to Z to G to F to E, and then let's split off into H and K and I and J, and then maybe eventually we'll get back to C.5. What's C.5? Well, it's as close as we could get to C. Yeah, I think we're probably only going to keep the Torch C++ backend for like one major update anyways, and then it'll be into just CUDA. Oh, we're updating kernels. Good. I mean, the profile for kernels. Good. It's at least nice. I do at least want to see if we saved some code by doing this. There's only so much I can do with Torch being the way it is. But I'm going to do my best to at least get this to be reasonable. It's getting closer to being human editable, finally. Yeah, go ahead and find everything. Six 688. I believe that's minus 150-ish lines. And some of this stuff is stupid. I'll help a little bit. And then we'll see whether this does anything better for us. Okay, the thing I wanted to look at here before I got distracted was clip coef, reasonable, VF clip, we got a couple sketchies here, I think. We got a couple sketchies. We'll have to double check this. But the normal clip coef is good. Oh, what's this? We got a 4.3 second solve. Cool. So we are making some progress. Change this. Yeah, this will clean up. This will save us a few lines. 688. And then we've got a whole bunch of advantage crap that's going to get compressed. Oh, and torch tensor. Hello. Yeah, it doesn't have the using deaths. Okay, so we have a lot to clean up then. Sadly, it doesn't make the most sense to just be doing this with Claude at the moment, which is kind of annoying, but... Sir file. Codex person. They both suck, dude. Look at what I'm doing with them. I'm doing very, very stupid refactor operations that would take a long time because there's a bunch of crap code. It's not solving anything. Like, look, see this diff? Such like a no-nonsense person. I can be. He's good puffer. Funny. I mean, realistically, like, can we just send the Claude code bill for this refactor to the Torch team instead? Because it's their bullshit code is the reason that this is such a mess that it needs to be cleaned up this much. Best third-party library you haven't needed? Raylib. Raylib, you want good software? This is good software. This is how to write code and not be a moron. Like, every single part of this project is just great. Here's their math. Here's Ray Math. Super, super nice, simple C. You go look at their docs. They have awesome, just like simple cheat sheet docs, plus lots of examples. Everything is super succinct and simple. This library is a joy to work with. Like, if you want to just, like, see what it feels like to work with good software versus bad software, play around with Raylib. It's like, wow, I enjoy programming. Oh, that's what it says on the front page. A library to enjoy programming. Yay. And then you go Torch, and it's like, I have crippling depression. It's like, I can't even twist my brain into this, like, idiot space that it would have to be in to design some of the crap that's in this library. Code is just awful. When are you going to convince him to start writing some ends? Rayson, he's got better stuff to do. Rayson does enough building Raylib. If any of you are using Raylib, go check him a couple bucks a month though on GitHub. It actually really helps him out a lot. I don't ask for donations for Puffer. We do our stuff B2B. He doesn't. So that actually helps him a lot. And of course, Puffer is one of the sponsors as well. Okay, how much shorter is this? 670 lines. Okay, that's at least substantially better. Now we have 656 lines. That's minus 200 from earlier today at the very least. And PufferLib C++, 811. I think we're still down in lines from earlier, despite having had to have done one growth thing, which is, yeah, these couple growth functions. Copy function is still fine, advantage function is still fine. Pretty much just this thing. So I think that's fine. All right. Good, that's what we expect. This is not supposed to solve. These hypers are bad, but this is what we expect overall. And 6 seconds is matching perf from before. Good. Very, very good. Finding. Minus 120 line commit. Minus 120 line commit is nice. We're always down to strip more code. Getting harder to cut code though. You know, that was a good couple hours of work for minus 120. It was a good minus 120 though. It should have been more. It should have been like substantially more. But we will accept that. This is still going. We do our word count. Try some env ideas. Always welcome. Okay, so we have 800 in PufferLib, some more in models. Move on. And then we have kernels, modules is shorter. Generally pretty happy, I'd say. Generally pretty happy. So I suppose then, where is remaining complexity? This is fine. This is shit bindings. We can maybe look at this, but there's not going to be much to do here. These are all our models. This includes, yeah, our default model and a bunch of our like C++ backend. This is fine. Custom models, fine. Most of this, we can probably save a little bit here, but like not too much. End finding, muon, modules, H, puffernet, dot h. This is separate. That's not a thing. And the big files, kernels, possibly there's some savings in there. Modules is now at least substantially cleaned up, maybe some in there. I mean, we're probably within 500 lines of the, we're probably within like 500 lines. We can just delete squared.cu and squared torch if we don't decide to do GPU env binds. We could decide to do GPU env binds, it would be super simple. Honestly, at this point, the really the only two significant things left are, like, there's going to be minor cleanup and I have to spend some time on it, but the only significant things are whether there is some savings in NVEC still. I got to chat with Peru about that. And how our sweeps are going overall. I think those are the only two significant things. Unless I keep finding more of these, like, more of these random cleanups. But that to me seems like the last big one we're gonna get. Because that was like a pretty nice find and it's only minus 120. Right? Yeah, only minus 120. Let's see what this run is. Okay. Ooh. Tiny, huh? Skip is 4. Skip is 4. Back. Oh, actually, this is kind of what we were expecting, right? 496 total agents. Train. Beta 1. Beta 2. Clip. The heck is going on? Here. Gamma. Maxed learning rate. To increase that. Massive mini batch. And then min prio alpha 0.1. Well, beta 0. Is this. And VF clip coef. So very reasonable clip coef. Very reasonable VF coef. B trace C clip. Trace. Clip. And then total time steps is 94 million. We get everything? I think we got everything. Yeah, Jess, I think that we are, holy crap. Well, that's cool. Where's the SPS on this? Well, it's not going to tell me, right? That's going to be crazy SPS. That's 13 mil SPS on my low-end machine, for reference. Right? Yeah, that's 13 mil trained on my low-end machine. That's insane. And that's a solve. That is a solve. Yeah, this is going to be way better, I think. That's nuts. I'm not disappointed by the smaller nets either. Like, that's kind of what we expected from the update. Simpler end would make use of smaller nets. So Jess, there was a major bug fix today. And it requires us to rerun a bunch of sweeps and retest some stuff. But that's kind of what I'm working on. I also got a nice refactor in, minus another 120 lines for us. So that's good to have. Let's just detach this so I don't kill the sweep by mistake. Put this on my other monitor, in fact. What was the SPS on this? Oh yeah, 23 million FPS training. Yeah, cool. Okay. 23 million FPS. That's, to be fair, so that's fewer agents, which should be worse. But then that is, more, was it fewer agents and smaller network size. So that's not like, that's not a perf improvement benchmark, all right? But that's still nuts. 23 million steps per second. What was the bug? Waiting thing? No, Jess, that's not. The thing in the Discord is very minor. This is a much more major thing I found. It's kind of complicated. It had to do with how we were computing, how we were updating rollout buffers. Essentially, it wasn't able to use any of the prio replay stuff if it wanted to, and it wasn't able to correctly clip value functions. There were several things wrong. One of the bugs was actually in 3.0 as well, so this should even give us a qualitative boost over 3.0 now that we're fixing it. And here's our 4.3 though. 546 experiments run. This is everything I've always wanted with Puffer. This is everything I've always wanted. We will let this finish. We'll find something else to do in the meantime while we run this. Patch be added to 3.0. Just 4.0 just, but we'll also add it to the Python backend for 4.0. Because you have to resweep everything is the problem. It's like, there are two types of bugs, right? There's the bug where like, oh no, we had a bug, our results are invalid. This was not one of those. This was like one of the bugs where, we had a bug. Oh, our results get even better once we patch it. Cool. Right? You're allowed to miss those. Well, now that this works, I think we can kind of afford to just chill and do some general refactoring for a few hours. Because, like, for the most part, we want this sweep to finish. We want to verify some results. And we'll want to run 2048 sweep. We'll want to see those results. And if stuff is relatively sane again, we'll be good. If not, it'll be a few more tweaks. And it's mostly cleanup from there. Mostly cleanup. But it looks like we're making good time. I'd say we're making good time overall then. Yeah. Okay. I'm gonna go get some tea. I'll use the restroom. I'll be back in a few. And then we will continue on some refactors. This is 550 experiments just while I've been live, so nice and speedy. pretty close here. I think via additional tuning, we're going to be able to get this under 3 seconds. For sure. It works so far. So far, so good. So far, so good. Refactor and chill. Refactor and chill. Get some music, maybe. I think what else there is to do. No, because... Well, it depends how much of it is going to be Claude versus manual. Do I have more stuff that needs Clauding, or can it just be manual by now? Let's try some stuff manual, and we'll see if we find any jank that's like super... So the thing is that like anytime... When do I use Claude, right? It's when shit is super redundant. That's when you use Claude. And the goal is to get the code to not be super redundant. But that's easier said than done when you're working with Torch. I mean, I suppose I could allow myself to, Okay, there's one last thing I want to just check with Claude, because it's probably a waste of time, but... I just want to check this. My intuition is it's like a medium amount of work, and I don't want to do it this patch, unless we happen to finish stuff early. And I don't think, unless this is like, oh, that's super easy, I actually just do this, and I go, oh, I'm a goober. I don't think we're going to do this now. I just want to have this in mind, and then what we'll do is we'll just kind of go through and clean up some, we'll just kind of like go through and start cleaning up stuff in Puffer. Monkey type, it's like 90 max, man, it's not great. Because, like, I make a lot of mistakes. Yeah. 90 peak, maybe. I guarantee you that's achievable by literally anybody, because I promise you, you've like never met anybody with as bad fine motor skills as me, okay? Not hard at all. come on. Gonna do this to me? Do I do it? Alright, I'll tell you what we'll do. I'll let Claude try it, and I'll see what it looks like. If this is going to take any substantial amount of time, we're not doing this now. I said that we were going to delay this for like future updates. The only reason we're doing this now, like at all, is because it might literally be less work than figuring out how to clean up stuff around Torch. Would you watch? No, 24. I'm not watching that thing. I think that this is actually going to end up being like sort of medium complexity, because it's not 4 intermediate activation tensors, right? I think there are quite a lot of intermediate activations. But you know what I want to do? I want to see the if the line count is shorter, even with Claude's shitty version of this, then I think it's worth looking at. AI Summit. Are you looking? I'm not going to Delhi for an AI Summit, my guy. I'm barely traveling domestically for conferences these days, let alone internationally. What would it take for me to want to like fully commit to doing custom? Just speed, right? I'm bugged. Knowing what will happen. Really? What? Is this the NVIDIA one or what? We're just gonna see if you can just drop Torch AutoGrad entirely real quick, Jess. We're gonna see what happens. I mean, because, like, essentially I've refactored this to the point now that it's not doing very much for us. So I'm going to have to spend substantial time in the next couple of weeks cleaning up Puffer. And it is actually possible now that it is simpler to drop the autograd and clean that up than it is to clean up torch with autograd. Mug holds a single tea bag. Kind of. I mean, I did one this. I've had 3 mugs of it, and I like started with 1 tea bag, and I just added a new one every time. So it's probably slightly stronger by the 3rd mug, but not by much. Cool. PPO lost backward. Huh. Black tea does not have more caffeine than coffee, not even close. Unless you're drinking the world's strongest tea and the world's weakest coffee. Okay, I'm gonna let it do this. And we're just gonna essentially see if the code's shorter or longer. If the code ends up being shorter and the same speed or about the same and much faster or anything like that, then we will consider. Because the autograd is the source of much pain at the moment. I don't want caffeine. I'm intentionally drinking weekly caffeinated stuff. I've had way too much caffeine in the past. How are we doing on this? Any new good runs? Not really. Looks to be about 4.3 seconds is best you can do. And around 5 to be comfortable. A little weird that it's like not immediately faster. But I think the other one was very well optimized, and it was also kind of janky, right? Like, I don't think it was super stable, so I think there was more RNG in the other one. I think it was 4 or 5 seconds in practice. This would be really funny, wouldn't it? What are we gonna... what are we gonna do if this does work, right? I guess then we'd keep torch C++ for the native path. I think that the initial version of this will be maybe slightly more code. I do wonder if it'll be faster. Let's get a quick speed test. We're at like 12.5, 12.8, something like that on the low end machine. There's so many things we haven't even touched yet for this, man. We haven't even tried Horizon. We can totally change Horizon. We haven't really tried the number of buffers. There's so much stuff we can do. This would actually make it easier, wouldn't it? In some sense. We'd have like a really nice self-contained piece of CUDA code. We can bind it to torch at whatever level we want without having to deal with it in the middle. We can probably just export the graphed version of it to Python directly. I am not sure what I'm going to do yet for like baselines and fallbacks, right? Because we have our full native path, which has all our kernels. We've got a C++ fallback that you could run. I could have a pure Python, like pure PyTorch version that you could run, and we might even want that just to benchmark how much faster we are than Torch. I could also export, just our core network and stuff, and I could have that be in PyTorch. So we could essentially just say, hey, provided you're not changing our core network, we can get you half the speed in pure Python, maybe something like that. Really, I think that the most important thing, though, at the moment is just getting these sweeps done, because as soon as we have confidence that the sweeps are now good and that the hypers are no longer jank and we start getting results in the right direction, then we're pretty much like locked on release and everything else becomes pretty high confidence, and it's just a matter of getting the work done. Alright. I'm fine with that. Except on is fine for this, because if this doesn't work, we're just going to revert and stay through it anyways. We're going to consider this like an experimental for the hell of it for fun thing. And if this doesn't work in like an hour of invested time and we don't see signs of life, then we just won't bother. It would be really cool though. It'd be really cool. And then it wouldn't even be like, I wouldn't even be wasting time at that point, right? Because the amount of time I would spend cleaning stuff up to be native would just be the amount of time I would spend like working around Torch trying to clean crap up, right? It wouldn't even be bad. In gaming, this is known as zero timing it. Yeah, zero time delete torch. Sounds good. Alright, so it is going to add a fair bit of code for the manual backwards initially, at least. I suspect it's going to end up shorter, though, in the long term. Or in the not so long term. And that is super simple code. You know, if you're looking at it, that is like super simple code. No C++ classes, no like janky variadict autograd bullshit. Nothing. You know? Whoops. Don't let it start building crap. What's missing to go 100% CUDA? Almost nothing, Liberty. Almost nothing. Okay, so that matches. What's actually slower? Which doesn't make any sense, right? Have accept edits on. Why are we not just ditching torch period? So we definitely need to bind to it either way, Jess. It's just a question of how much of it we strip out. Like, it could literally be that we strip the entire thing and then just it's puffer and then bind to torch so people can also extend with torch if they want. PPO loss forward backward. Oh, wait, it wrapped. Hang on. Did it wrap their weird autograd? I bet it wrapped their autograd and, like, is still doing that overhead plus. No autograd. Oh, it's allocating every single step as well. So this can definitely get optimized. That's such a flex. Yeah. It'd be nice. Keep gradient flow in BF16. Prio data, log probs. Hang on. Is this what they do? Weight grad map mole. Stay. Make sure. I want to make sure we're actually isolating autograd overhead. Like the shirt. Thank you. The shirts are all Vori. Which I guess it's like a trendy whatever now, but I don't know. I found Vori when it was just like, they just had a couple stores before they blew up. It's the only place I actually like shopping at, I swear. Because they actually have new stuff that's like good and comfortable. Vori. Free advertising, I guess. I think the only complaint I have with their stuff is that the like shorts and thin sweats don't last very long if you run in them. Everything else is pretty awesome. Oh. Well. Good. Danke. Yeah, these are the Strato tees. The one other thing is the heavy sweatpants they have. I forget what they're called, but the heavy sweats are like really nice. They also make the world's most comfortable pajamas, but only for women, which sucks. Good present though. We're just gonna let it do all this bullshit, and then we'll see where we end up. It did not say to build it. Are we faster? Are we functional? Let's see. Wasn't this where we were at before? I said we were at like 13 mil. 12 to 13 mil. So it's now same speed, right? I mean, if this works, right? There's no reason to expect it to not work. I guess the only question is the magnitude of the speedups that we should expect from this. We already have the CUDA caching allocator. I guess we'll just look at the code after and see if this is worth it. We wanted to do this eventually. The question is just, do we do this now or not? I said I'd spend an hour on it. What's it been, 30, 40 minutes? Not even. So we'll give it a little bit of time. Initial results are like pretty decent. Let's go take a quick look. So this is the new, if we kept this, the new PPO loss would be like this, right? One function. You have your launch directly in here. How much do you code manually versus using Claude? Well, it depends. If the code base I'm dealing with is a complete piece of crap, then there's a bunch of Clauding, unfortunately. If you see me writing CSIMs, very little. Right now we're in a transitional phase where Torch is a piece of crap. The thing I'm trying to build should not end up being a piece of crap. And getting it from one to the other is Really obnoxious. You definitely don't want to make the mistake, though, of thinking that the models are like good programmers or smart or capable of sophisticated reasoning, because they're totally not. They're really stupid. But they've read the entire Torch source code without getting bored. How do you approach CSIMs? What's your strategy? Write the code in the simplest, dumbest way possible from top to bottom, and don't allocate memory all over the place in the loop like a goober. When you first started 4.0, what would you tell? Ugh. Yo, this is gonna totally suck. You're gonna learn a lot. You're gonna spend a bunch of time getting bullshitted by Torch. I don't think I could, like, it's a lot of information is the thing. Like, the extent to which Torch is just truly, utterly garbage is very difficult to convey. I mean, how do you convey... I'm going to have to write a really big, long article, ultimately, for the release. Because how do I convey that every single possible portion of Torch is just complete and utter crap, and they've made every wrong decision they could possibly make? There's not a single time I've gone and looked at Torch and gone, oh wow, that's pretty clever, or that code's pretty clean. Not a single time. It's going to be a nice long article, Jess. Probably multiple. I mean, there's a good chance I just end up spending a week writing. Spencer's going to kill me for doing this, I swear. He's going to be like, why are you fucking replacing Torch? But, I mean, I think it's literally going to be easier than refactoring the code around Torch. We'll see. Like I said, we'll give it a little bit of time. If this is actually somewhat faster and is not broken, though, then this is motive to keep it right here. Because I tried to do this exact same operation with Torch beforehand. I spent an hour doing it with Torch, and I couldn't do it because Torch was a mess. Does it affect the existing M's? It really doesn't. The thing is, there's very little required on existing M's crit. There's a very small port up to 4.0, but like I'll just do it for everybody because it's super easy. It's very, very little change. The networks change. A lot of other stuff changes. Real opportunity for the Primogen vid. I mean, he seems chill. I actually, when I was like moving off of Python, some of his videos were quite helpful. I think like a lot of the reason I started like trying out more procedural programming was some of his stuff. Like you gotta understand, I was not trained as a systems programmer. I had very, very little low-level dev experience, and I did spend about a decade just trying to figure out how to write better, simpler code, and actually caring about that, not just sort of brushing it off as, you know, code is the means to the end. So I sort of had my mind in roughly the right spot a lot of the time. So it was very, very natural for me to go to C. It was actually like a very natural change. It only took a few weeks before it was super chill. And then most of the problems I've had have not been in the low-level dev. Most of the problems I've had have been interfacing with all the other crap out there, right? Get him to promote you. I don't know. You're probably chilling somewhere. No, you don't run setup. I run setup. Is this faster? Flash doesn't still work. Oh, uh, is that a little faster? I think that was a little faster. Yeah, it's a little faster. It's small, but it is a bump. Is this worth it? Let's see what the code looks like. This is sadly, this is going to end up having to be very, very heavily clawed crap until we get it into a new form. It'll mostly be remixing my own code, which is at least something. What did it do? Wait, did it take out CUDA graphs? No. Okay, it still has our CUDA graphs. We can do contiguous rad buffers now, right? Rad logits. We should be able to now, right? I'll tell you what, it's only 2 p.m. This looks promising. I got a bunch of stuff done earlier today. I will allow myself to run this, like to do this experiment of seeing what happens if I go down this path. Worst case scenario, I lose a few hours and I have a very good understanding of the challenges that face us for Puffer 4, and it better informs how I'm going to refactor the old version. Best case scenario, we make Puffer significantly faster, we make the code simpler, and I get to stop bitching about Torch being a piece of crap all the time because we won't be relying on it in the ways that we were. and you all get to see something kind of entertaining, which is like Torch actually not doing things and getting stripped out. Let me see if I'm actually correct. Oh, look, it's, wait, grad logics, hypers, kernels, grad, where are the logic buffers? Oh, let's see. Encoder. Do we still have register module? Forward train. No, we have the manual buffers. Okay, hang on. In that case, because that was the other big update that I wanted. I wanted to have it be contiguous. Offset per param. I don't like that. Try this. I think that this works. Add buffer, update buffer. What's the update buffer? All updates. And then what? We would have move on can just write back into the same one, right? I think that works. Try this. Way too much fucking clotting here. But the good news is we are trending towards the direction of less towards bullshit that requires this. Because, like, I keep having to make these big refactors to work around torch crap. But I keep reducing the amount of torch crap. So in theory, as we approach zero torch crap, there should be less reason to need this stuff. Zero Brad. This should be noticeably faster. This should literally be, like... I mean, that's actually a pretty big buff, isn't it? Contiguous grad buffer. I remember contiguous weight buffer being a pretty big buff. Contiguous grad buffer should definitely be a big buff. That'd be pretty cool. Right? I will build. I bet you it is screwed up though, because I didn't see it updating. It didn't update the policy, did it? Yeah, so this doesn't work. Cool, but that's expected. Oh yeah, we can at least speed check though, right? See, now I think it's doing both. So it's slower because I think it's doing both things. It's writing into the non-contiguous and it's doing the contiguous. Yeah, it does. We probably even can optimize further by doing it as one big cast. We shall see. Accumulate, yeah, that gets away. $737. Any new runs? I think this one's still the best. A lot of good runs. Okay. Breakout. The copy handles the cast and then directly writes into the buffer. So that can get optimized. All right. Still doesn't train. Wait grads via params mutable grad.copy. Ask Codebase about the Codebase and learn what each. What? Crit? What Codebase? The snake env? Read the functions, man. The snake env, it's first year undergrad level C. There's nothing fancy in that env, I promise you. If you just read that file from top to bottom, it will be very simple. It's only like, what, 200-300 lines? I thought the grabs get accumulated in FP32. I'll have to check that. I'm sure it just forgot. It probably just forgot to, like, put these into the buffer or whatever, right? Yeah, look, like the default encoder, the default decoder. It's super easy. Training and inference functions are basically untouched, which is super good. This manual buffers thing is going to get overwritten anyways. Cool. I'm going to use the restroom real quick while this does whatever, and grab a new mug of tea. We will continue. I will be back. Okay. Sent you a funny. What we got here from Jess? Funny. That's silly. This thing has just been chilling for 7 minutes doing nothing, which is kind of cool. I went, I made myself a new mug of tea, I came back, and it's still doing nothing. That's kind of silly. Now, this is the problem with these stupid models. But I can totally see it, right? Like, it's just not using the grab buffers for encoder and decoder, right? Yeah, it needs to define a backward function. I don't know why it's just stuck doing nothing. Is this Control O? Wait, how is it this stupid? Are you kidding me? It's done all this crap? Oh, it's just going down a rabbit hole. Mm-hmm. Dude, this is such an obvious thing. Why is it so dumb? Okay. Hang on, let's make sure I'm not dumb. Forward kernel, backward kernel. You know. Let's see. Let's figure out why this thing is messed up. Backward manual. PufferLib policy backward manual. Oh, it does have the encoder backward, right? Wait. It does have the encoder backward. Okay. So that's why it's confused. Yes. Wait. Yeah, that's the point. What? Mutable grad. I see, because it goes through. Muon 0 grad. Zero underscore. Let it do. That seems weird to me. I think that would seem weird to me. So it's just thrashing. No, this is trolling. What the hell did it do? Stupid thing. Where's clip grad norm? Okay. set requires grad. We're probably mixing auto grad. It's got the no grad guard. Yeah, this has got no grad guard. Let's sort this out. It's actually a lot of stuff is going to get much, much simpler, believe it or not. Okay. I don't have accept edits on. I don't know why it just like is allowed to do this. Not permitted when stream is capturing. Lovely. Okay. Are these our only parameters? Let me think. Two layers? Oh. Those are literally our only params, huh? How far into training does this collapse? They match. That'd be funny if we broke stream somehow. Let's see if it works with CUDA graphs off. That is kind of believable, right? Nope, that's not it. Nan's out. I mean, that would be the best guess, would be that it's still doing autograd somewhere, right? Then our entire thing gets to run under no grad, which is cool. Hey, Antonio. We're attempting to replace Torch, because I think it's going to be easier than working around Torch. At least Torch is autograd. We'll keep their tensors for now. The funny thing is that if we did replace it completely, that would also fix our compile times. Optimize tensors somehow. In CUDA graph mode, there shouldn't be anything to optimize. Yeah. Non-CUDA graph, you could very well optimize. You could probably get the non-graphed path to be very, very close and perf to the graphed path, and then just not need paths, not need the CUDA graph path. That'd be pretty cool. are we doing on our experiments? Still, this is the best one. We got a lot of ones over here, though. 4.3 seconds. That's pretty good. 2/3 of the way done with the sweep. I think I set it up to run 1,200 experiments. Much nicer than before, at the very least, with the hypers. So assuming we can fix this bug in relatively short order, contiguous gradients, merge a bunch of crap. Things somehow get simpler. Figure out what we do with non-kernels and how we do that whole shenanigans. Probably that makes probably that's actually going to put us in a pretty good spot. And then what? We would just like export. We'd export like a few core things, I suppose. Like we do the graphed loss, for instance, or was it the loss? This is one kernel, doesn't even need to be graphed. So we'd export this, we'd export the network forward backward, I guess. A couple other things. I can think about the Python stuff after. It's kind of secondary. Could be this. Is there any reason we can't just like can we just do this? Nope, that's not it. Dang. I swear they just set it on, like, you know, pay us free money mode or whatever, because it's not doing anything. Init manual buffers. Yeah, why the fuck is it even doing this, man? Dot grad combined. Layers. Like, what? Why are we doing this? Yeah, this whole thing makes no sense. These nuts are incredibly dumb. I see. Grad deck out buff. What? Just the recursive self-improvement is just going to be when there exists code in reinforcement learning that is fast, that doesn't suck, and we can go, oh, that's pretty simple. Now this makes sense. What if I tried this, this, and that? Oh wow, look, the field's way better. Isn't it awesome when you have fast code that doesn't suck that you can actually understand? That's what's going to happen. It's just a lot of work to get there. Summary. Yeah. Oh, that's what you mean. Recursive self-improvement, not of the RL code, but of the agents. I mean, that is something we can actually think about. Hey, bros on Twitter. Well, I don't mean recursive self-improvement in the sense that it's just like, oh, it solves everything somehow being trained on breakout, right? I mean, like, you get something that continues to make progress over time more rapidly in a hard environment as it starts learning the dynamics. Same language. Yeah. I mean, well, those guys just have no grounding whatsoever in reality. Ah. Okay, this what it's checking here is what I actually wanted to check. If this doesn't work, we're just gonna go back to the joint buffers and then try again. I'm starting to be able to see in my head what this code is going to be able to look like, and it's so much better than this stuff, man. It's so much better than this. I know I'm gonna have to pay, just stock this thing another $100. It's gonna have just wasted $100 on nothing today, I'm sure. But whatever. It doesn't find anything in the backward kernel, though. We'll just go back to the original, and we'll not use the .grad buffer at all. What is it doing? It's just in a rabbit hole doing fucking nothing. It's so stupid. Okay. It's literally it's like if you read the words, it's very well put together. Oh yeah, it's doing things. But if you actually look at the content, it makes absolutely no sense at all. Oh great, so we just lose the whole thing, huh? That sucks. Now this is what I get for losing Claude like an utter imbecile. Um, this is why you don't do this. I need to get Torch, garbage C++, modern C++, and all this bloated crap out of my workflow, and then yeet these stupid models with it. So frustrating. Is there a revert? Of course not. Fuck off. Okay, they did actually include a feature, so good on them for once. Commit this. How is this not training? Are you shitting me? This absolutely trained before. Did it rewind wrong? I had this built. Never mind, no props. Thing sucks. Well, it was training before on this version, and it's not training now. So... Okay, this one trains. Okay. This version is fine. we'll start from here and we'll actually be a lot more explicit about everything. Because it seems like this does work. It's just going to take a little bit of effort. I'll be back. What a mess. Trying to support both paths. That's the problem, right? Okay. Gonna have that. I guess I do need to have that as a sanity. Yeah. Shit. early to do this. But we kind of have to if we do it this way. Hang on, if I keep it like this for now, I can kind of do both. It's a shitty intermediate build, isn't it? Hey, chicken. Yeah, I think what we want is we want to have a full native version so we can kind of see where the code is going to and see that we are actually producing something simpler. And then we'll have a much more complicated version that we'll use for backtesting and crap. But I need to be able to see the simple version, like ASAP, and see where it's going. 908. It's looking pretty good. What's their maximum number of points? I don't know if it actually has all the points on here. Yeah, because this will end up being actually pretty simple. Hey Finn, we are fighting Torch. I think we're basically going to be able to replace it though. Yeah, we will pretty much be just able to replace it. Let's go. Sounds good. Yeah, I didn't want to do this in 4.0, but it became obvious that one, we're leaving some perf on the table, and two, like, I don't want to spend 2 weeks cleaning up the code to be as good as possible for it to, like, still be kind of crap because of Torch. Like, it's going to take me the same amount of time to just get it into something that's clean and doesn't really heavily depend on Torch. I mean, we'll probably still use their tensor class. Maybe. I'm just trying to figure out how I want to do the activations and stuff. I think it's not that hard, right? We'll just pass an allocator. Still happy to give 21st. Yes, keep reminding me so I remember to make my talk fin. Because I've been thinking about what I want to do, but I have to actually like make a talk. It's next Saturday, right? Yeah, it's in a week. Okay. It's actually better. I'm gonna keep this on my local for a bit at least. I might just have to do a morning session tomorrow, honestly. On this, it's just so much work. It's like every time I think I've got everything the way I wanted, I go, you know, this kind of sucks. Error. Come on. Forgot the bindings, dude. You need to leave. It's only 3:40. Lovely. I mean, the good news about this is we will legitimately just end up with like PufferLib.cu or whatever. It should be very, very short now that I'm thinking about it. Stop trying to run build commands. Yes, okay. Name parameters. It's okay. This still works. We're happy. This works. This is unfortunately going to be a lot of like hacky nonsense here. The final version of this I have in my head is going to look like, it's going to look very, very simple, but getting there takes some work. Since this is not strictly necessary to the project, I think what I'm going to do to compensate for any time offset that this would take, which I don't think would really be much, but just in case like this ends up taking me a couple extra days, I'm just going to put in some extra hours over the weekend and early next week to compensate. I mean, this is actually genuinely exciting to me though, because if we can get Torch out of there, like the idea of just having clean, simple RL code is so good. It's like so important, and Torch makes it so freaking difficult. But I think I'm kind of seeing the way that we're going to be able to do it, and we're going to be able to keep our stuff Torch compatible for the most part, without making it a mess. Like essentially, right? It's just we write our code the simplest way possible, and then we're going to bind to Torch. The Torch binds are allowed to be a mess, because it's Torch's fault, damn it. And in the meantime, we still get to just finish, like, keep running all these experiments, and I don't have to pull this code on the remote machine where I'm doing this. And I can just kind of run our new experiments. And then, on the new version, we basically just have to make sure that our optimized runs repro, which is super quick, and then we'll know everything is stable. And we can even compare the timings, because it should be a little bit faster, just a little bit. And we're getting a very nice Pareto curve here. It seems like 4.3 seconds is the fastest on this, though. Now, there's Wanby overhead and other stuff, though. Maybe not the worst. Clear context, hang on. Allocator. The bar on this is going to be so high for the simplicity. Because if I'm going to give people something that doesn't look like the thing that they're familiar with, it has to be so freaking obviously better, it's not even close. I do wonder if we're going to even end up needing CUDA graphs by the end of this. It sort of depends. Let's run. Oh no, wait, it's not done. Nope, don't run the build. Come on, man. This shit again. Two monitors. Back to using, I hate this, Jake. The goal is to frickin' completely delete Torch, at which point I won't need it. I got it very, very close, and then I looked at it and I'm like, it's gonna take me 2 weeks to manually clean up this code in order to only have something like I'm only kind of okay with, because like of all the Torch jank. Like it'll literally be the same amount of work, pretty much, to just replace Torch at this point. Because Torch is doing basically nothing. I could honestly even replace their tensor class. And even that wouldn't be that hard. Why replace it is jank? Because it's literally forcing me to write slower, longer, worse code. Trying to make Torch fast is literally more complicated than replacing it. It's so bad. There's literally not, like, when you're doing actual high performance stuff on nets of various sizes, including small ones, it has just no redeeming qualities. There's not a single goddamn design decision that they made correctly. I mean, I need to get this like contiguous buffer thing to work. Because the thing is, until I have the continuous buffers thing working, I'm still sort of dependent on their like parameter handling and stuff. When I get rid of that, we're set. Then I can get rid of their linear. I can actually get access to the mapable functions that take out params, so we can have static buffers. Should actually get a fair bit faster, even. Hell of a lot simpler. Let's see if you actually found the bug, or if you just hallucinated some bullshit out. Okay. It works. Good. We're gonna make a quick commit. Jax, Flax, and Torch. There's no comparison. Jax is just straight trolling. That shit's awful. Look, at least Torch's low-level backend sucks. At least they have one. If I had to do this shit in Jax, it's just I fucking quit. I'm gonna go pick another field. Like, As much as I rag on the meta engineers that like overcomplicate the crap out of Torch and make everything slow for no reason, like at least they're not the Google bros that think they're geniuses writing Jax. Making a proper Torch replacement. It's gonna be pretty close, Jess. Like the thing is, you don't need Torch but better, right? That's the key thing. Like you need not Torch. Like 90% of the stuff that's in there just doesn't need to exist, and you're better off without it. There's very, very little you actually need. It's like, oh, but it's so convenient. Well, is it convenient when you have to end up writing more code that is slower, dealing more with more APIs that suck, that shouldn't exist? Like, no. Not at all. Like, you basically need a tensor struct, and you need some kernels, and that's it. This is fine because we never have to accumulate in activations. We only have to copy. We'll see if this breaks it or not. Something more complicated. There's not a way to make that not bloat. Okay, yes. To be fair, Jess, you could make a decent autograd. You're right. You could make a decent autograd. I suppose autograd itself isn't fundamentally screwed. It's the implementation of this autograd that is screwed. That is fair. That said, I do think the importance of autograd is vastly overstated, but it is true that it's pretty easy to have annoying errors by doing the grads manually. Like, fine. At least I think it is conceivable that a decent autograd that you would use for some stuff could exist. That's about the strongest you can get. Well, because Jess, if you get like literally anything wrong with it, you're better off not having it. That's the problem. Mini batch segments. I don't know why it's getting rid of this, but cool. Oh, okay, just moved it up. That's fine. You don't build, I build. Okay, reasonable. Interface with it more. No, it's the design, Jess. It's down to the core. Everything's allocated all over the place in fragmented memory. Activation buffers are dynamically allocated and destroyed all over the place. The stuff that you need to like make it fast doesn't work and is only in Python anyways, and comes with a compile your Python time overhead. It doesn't actually fuse operations the way it's supposed to make it fast. If you write custom kernels to fuse your operations, it makes it hell by introducing a really clunky modules API that's like makes you write hundreds of lines of boilerplate crap everywhere. Um, their mixed precision doesn't even exist in the C++. You have to write your own. That also means you basically have to do your own optimizer. Their distributed is literally harder than adding your own distributed in and slower. What else? Oh yeah, CUDA graphing is absolute and utter hell because they have their own CUDA graphing wrappers and do a bunch of weird stuff with your CUDA streams. You have to CUDA graph because every single op and torch has a bunch of checks and shit that bloat everything ludicrously. What else are we missing here? That's just most of the stuff off the top of my head for now. It's pretty much everything. Anything you point to is wrong. You point to it, it's wrong. It's that easy. Okay, cool. So now we have this linear. Nice. Where's encoder? So our num subclass as well. Think so? No. Matmul out. I will write a good article, Jessa. Yep, I will write a good article. We actually get to use this now. It's putting stuff all over the place in really dumb spots, but we don't care for now. Does it clear this buffer? I wonder if it clears the buffer. It probably, if I were implementing, it probably doesn't. Well, if it doesn't run, we'll know why. Which this can be slower, to be fair. This can probably be slower. But we're going to be able to do these in contiguous memory and do them all in 1-0 op, which will be faster ultimately. Gotta be. We are probably going to dip a little bit of perf on here temporarily. This will be faster. Ultimately, it will, because it essentially has to be. But a couple of these things are not implemented optimally right now. Like certain chunks of buffers need to be zeroed together, certain buffers need to not be zeroed. But this is what you essentially want here. I wouldn't be surprised if you drop a fair bit of perf doing this. Well, let's see if it's actually even stable. Okay, good. You do drop a little bit of perf, but not really much for having it not implemented efficiently. I will be right back. Let me use the restroom, and then we will... I got a little bit longer before dinner. I'll be back. All right, so this works. I'm just trying to get the basic stuff that I know needs to be there consistent. Hey, I have more to welcome. We are, well, we're rewriting very large chunks of Torch at this point. And I'm using this crap to like hack something together quickly. But then if we get this thing looking fixable and hitting perf targets roughly, then this will be what I end up doing, and I'll end up cleaning it up a lot manually. Well, in passes, right? I probably do coarse refactoring with this stupid thing, and then fine grain refactor manually. Yeah, you definitely need to do, there definitely need to be 2 activation buffers though, right? Like, there should be an activation buff. There needs to be a buffer for stuff that gets zeroed and a buffer for stuff that doesn't, essentially. Yeah, we get rid of a bunch of zero calls this way. I think 3 zero calls get deleted. Oh yeah, how's your sweep going? Almost done. Oh, we did get 852 in 2.98 seconds. So we're kind of getting the Pareto front nicely here, yeah? Like, right... Where is it? Come on. Yeah, there's your Pareto front. Pretty good. The orthogonal is for muon. Yeah, orthogonalization is for muon. Okay, let's see if it broke it. This may or may not be noticeably faster, but it is faster in general. About the same speed. Maybe slower. I'll fix that. Let's see how bad it looks. Okay, it just like inlined the encoder, which is stupid, but whatever. Yeah, it inlined everything because it's stupid. So this, like, most of this will end up going in the min group instead of inside the whole loop. Once that is done correctly, this will all be fine, I think. And backward, perfect. Yeah, this will be fine. Hey, AZ, welcome. Oh, this is Tosin. Hello. Welcome. I am attempting to fix a bunch of stuff in Torch. I couldn't find many papers on using Muon for non-LMR applications. From my experience, it looks like it kind of took longer to convert, but had more exploration. Eventually switched. So you have to retune the hypers. We have a blog post on this in Puffer 3. It was a step change for us. Like, Muon was way, way better for Puffer than Atom. We could technically go try those experiments again, but I'm pretty confident it should be better. It should not take any longer if you have a correct implementation of Muon. Like, Muon itself is quite fast. It's a very small amount of overhead. It's just the orthogonalization step, which is amortized over each mini batch. So it's a constant amount of time per mini batch. It doesn't, like, if you have tiny mini batches, it'll be slow. If you have normal, like, big RL mini batches, it'll be fine. And Atom W, I don't see the point in because you almost are never using weight decay in RL. Use heavy ball. Yes, the heavy ball works. It's just very bloated and complicated. Went over my articles. It's just puffing up PPO, right? I think it was detailed in, where is it? Suarez. Okay, stupid, I'm in the wrong browser. Let me find it. puffing up PPO. This chunk here. So a pretty nice change. And I think we have, the thing is you can implement here. Try this one. I think I still have it. You can just copy this into your code and see if it works for you. Muon.py. Try this. This is 150 lines, and it's the same muon as Heavy Ball has. You have to sweep the hypers. But yeah, Heavy Ball is just really, really freaking bloated. Now, I don't know if my implementation is fast in Python, to be fair. My C++ one will be very fast. So take that for what you will, but it does exist. It is there. Okay, so we have a ton of Alex, I guess. I got half an hour, and then I gotta start getting ready. Yeah, this is a whole mess of Alex. IROS in a few weeks, not gonna have time to try to tune it. We'll experiment after. Yeah, so the reason you don't have time to tune it though is because your stuff is slow, right? Here, look at this. This is Puffer 4. Alright, I started this sweep this morning. It has 1,086 experiments completed already. And we can see that we solved breakout in best time of 4.29 seconds. And then, of course, breakout is the fast experiment. We'll run overnight. We'll run on a harder environment. And we'll see if it checks out on a harder env. We have lots of envs to use. KL and entropy. I don't really look at KL and entropy a ton, honestly. Manually tuning hyperparameters is kind of just troll. Mm-hmm. Once we get all of this into static memory, first of all, we should get a bit of a speed bump. I can then start refactoring this stuff. It'll end up looking about the same complexity. No, I think even simpler than it was before. It'll take a bit of work before it gets there, though. I mean, like the whole CUDA modules, like it's all kind of a bit of a mess. This one's good. And Sully, Justin's a very smart guy. There's quite a bit in robotics, exploration, RL. Is this your first or second year PhD? I forget. Second year? Hopefully things are going well. I don't know if you've seen, I have RL at like 15 to 20 millisteps per second now. That's what I've been working on. Quals, fun. First non-workshop paper is good. Oh shit, yeah. It's really fast. I pretty much am having to replace Torch though. I hate that I'm here typing crap into Claude, but it's basically Torch's mess that I'm cleaning up with this. My hope is that once I get this into clean standalone CUDA, it's going to require little or no AI to clean this stuff up more. But it's a non-trivial architecture as well, man. This is not like, oh, I made a linear one-layer network or whatever. No, this is Mingro. It's got recurrent state. You can stack it. You can stack it like 4 layers deep, still 15 million. Solves all like the simple classic tasks in seconds. Smaller versions of it can push over 20 millisteps per second. I've seen up to 23 mil. It's pretty nuts. But I got all that stuff done, and then I realized, like, man, I cannot make this code as good as I want to make it because of Torch. So not only is Torch making it a little bit slower than it should be, it's also just making it way more complicated than it should be. It's really not doing anything for us anymore. Why is this getting adding me on this? Aren't there torch CPP bindings? Yes, they're slow. We tried that. Pretty much every single part of torch, including the internal C++, is just bad, poorly designed, and slow. This is also going to have instant startup time, pretty much, which is awesome. Like, you're not going to have to do torch compile type stuff. Your experiments will just have instant startup time as well, because you're not running a JIT. Oh, jeez. Probably this is trying to do too much and will break. We'll see. Yeah, it tried to do way too much at once. I should have just had to do one of those things. We'll see. Maybe we get lucky and it works. Lights out env. Manually playable. Cool. Building some EMs is a really good way to learn some low-level dev, learn some RL. A lot of the EMs end up being very useful as well. So we'll see if this works. It probably just tried to do way too much. Perf is not better, which is a problem, but I think it's okay for now. It's not really much worse. And presumably this is doing a ton of stupid things that I'm going to have to check. So this is bothering me, the policy here. Like, it'll just do stupid stuff like this, you know? The heck is it doing? It's just doing nothing. Very nice. Still gonna take quite a bit of work, I think. Matching parameters order. Why do we need to be matching parameters order? Yeah, dot parameters is sketch. Like, what the heck uses dot parameters? I have no idea what the hell it's doing. Great. At least we will have an idea what the hell it's doing by the time I'm done with this, which will be out of the workflow. It's annoying. Like, basically, every time I start getting it cleaned up, I start doing stuff manually and everything is good. And every time there's a major refactor need. But every time there's a major refactor need, it's because I hit some torch bullshit where it's like, well, I'm not leaving this in the way it is, right? Alright. Can do this. Bonk. Much better. Way, way, way shorter. Policy, forward, backward, good. Let's figure out what the heck uses parameters. Stop building. And figure out what the heck uses parameters. Come on. Good. A little better even. And solves. That should get rid of a lot of them. One moment. Alright. Yeah, I gotta get ready to go in like 10. We'll just go through this last thing. I don't think we're gonna get all of this done today. I'll probably just put in some time in the morning on my own and just like see if we can get the basic end-to-end set up for this and then start thinking about cleaning it up a little bit. I mean, the cool thing here is that we're using so little from Torch that at this point it's basically you just write a single CUDA file that does a few initialization methods, no blinds, cuBlast matmul, a couple other very small things, and you're done. Make a quick commit. Not even added a ton of it's not even added like a ton of code. Though I think that my objective here, I'd like it to actually be slower by the time I'm done with it, which I would think it should be able to be, because we're not going to have any of the modules crap. I just wanted to push it to a branch so we don't lose stuff. That'll be good. Test. I think there's still a few places. We have a lot of them, huh? I think this is a good stopping point because here, this is a nice clean summary. I can go off of this. There's several spots in here where like all these dot contiguouses are just going to be checks, asserts, instead of like, this is a, oh, just in case, call dot contiguous. No, that makes stuff slow. So I'm going to go through manually. I'm going to spend some time probably in the morning tomorrow going through all this. And the goal is that everything is fully static, which is what Peru suggested to me. It's going to look a little different from his info, but we'll get there. I got to talk to him for sure about some stuff. And yeah, we shall see. We shall see. For folks who tuned in, thank you very much. If you're interested in my work and you'd like to support me for absolutely free, feed the Puffer a star on GitHub. Really helps me out. Stream tomorrow, undecided. I'm supposed to at least take a day off a week, and I haven't done that the last 2 weeks, so we shall see. Discord here, if you want to get involved with dev, or you can follow me on X, which I need to update this link because I got my new handle. It's just J Suarez, no 5341. And follow me right here, and I got a bunch of articles and stuff. All right, thank you. Y'all have a nice evening on Valentine's Day.